everyone, and welcome back to the Science Corner. For today, we're finishing up Topic 2, Part 4. So Part 4C is today. We're going to watch a video, and then I will show you how to make a landform dinosaur. If you're going to make the landform dinosaur, you're going to need some crayons and a piece of paper. So you're going to need a yellow crayon, a blue crayon, and a green crayon. And if you don't have a piece of paper, you can draw your landform dinosaur in your notebook underneath your hypothesis that we've been working on for Part 4. So first, let's check out the video.
Wow, Geo! The Earth is filled with some pretty crazy land formations. There are piles of rock that reach into the sky, shifting sands that seem to stretch forever, and cuts so deep in the ground you can hardly see the bottom.
The different shapes on the Earth's surface truly are fascinating, Iggy. And each shape has its own name and story.
Ooh, I love stories.
Then what do you say we connect our databanks, and I'll share with you all the information I have on the Earth's land formations. Iggy, as you can see from all the blue here, the surface of the Earth is mostly covered by water.
Water, the most important liquid in the world. In fact, nearly 3/4 of the Earth's surface is covered by water. Only about 1/4 is dry land.
Correct calculation, Iggy. The Earth's dry land is found in several large pieces called continents. There are 7 continents on the Earth's surface: Australia, North America, South America, Africa, Europe, Asia, and Antarctica. Scientists think that many millions of years ago, the Earth's surface looked like this. There was only one big continent surrounded by one big ocean. But over millions of years, the land slowly broke up and moved until the continents took the shape they have today.
It's a good thing they've stopped.
Well, they haven't, Iggy. Even today, the continents are still slowly moving. In fact, all of the Earth's surfaces are constantly changing.
Well, speaking of the Earth's surface, I have to say that I'm most interested in those big rocks.
They're called mountains. Mountains are made of rock and are the tallest formations on the Earth, rising high above the surrounding land. Mountains can stand alone all by themselves, or they can be part of a group of mountains called a mountain range. Some of the best-known mountain ranges are the Rocky Mountains in North America, the Alps in Europe, and the Himalayas in Asia.
Oh, wait, I'm getting a file flash. Let's see. The tallest mountain in the world is Mount Everest, located in the Himalayas.
That's right. Mount Everest is very tall, standing some 8.8 kilometers or 5.5 miles in the sky.
That is tall.
But Mount Everest doesn't just stick up all by itself out of the ground. Many of the other Himalayan mountains around it are nearly as tall.
Wow, mountains sure are impressive. But they don't change, do they?
Actually, mountains change every day, Iggy. But most changes are small and go unnoticed for thousands of years.
Hey, Geo, just what are those things? They look like giant tables made of rock.
Well, yes, they do. Those land formations are called mesas and buttes. In fact, the word mesa is a Spanish word that means table. Mesas were given that name because of their very wide, flat tops.
What's the difference between a mesa and a butte?
Mesas are usually much wider than buttes.
Well, they're both beautiful. Geo, we've been talking about the raised land formations. But what about the land that's just, well, flat?
Well, Iggy, when a wide area of flat land is low, it's called a plain. Plains found near the seacoasts can be very good for growing crops.
And when the flat land is higher?
When a wide area of flat land is found far above sea level, it's called a plateau. But regardless of whether it's high or low, if an area gets very little rain each year, it will become a desert. With little water, few plants are able to grow there. Deserts can be rocky with scrubby brush, or they can be covered with loose blowing sand. The Sahara Desert, in the northern part of the African continent, is famous for its desert sand. The Sahara is the largest desert on Earth. In fact, it's almost as large as the whole United States.
Wow!
The burning sun there makes it the hottest area in the world during the summer. But at night, it can be very cold. Surprisingly, the Sahara wasn't always a desert. Only 6,000 years ago, it was a grassland, full of animals and people.
Really? Why did it change?
Because the surface of the Earth is always changing, along with the weather patterns in different areas of the world. Someday, it's even possible that the Sahara could become a grassland again.
Geo, let me take a moment and back up my files on these land formations we've been talking about. We've got mountains, which are the tallest land formations on Earth. We have mesas, which are wide, table-topped rock formations, and buttes, which are like mesas, only not as wide. The low, flat areas of the world are called plains, and the high, flat areas are plateaus. And both plains and plateaus can be deserts if they don't get enough rain.
Well filed, Iggy. Let's proceed, as we've only begun to scratch the surface, as they say. Islands are land completely surrounded by water. They can be low, flat, and sandy, or they can be mountainous. They can be found in the warm tropics or the freezing waters near the North and South Poles. The world's largest island is ice-covered Greenland. Islands can be found alone or in groups called island chains. The state of Hawaii in the United States is actually a chain of many islands, which are formed from volcanoes. There are also land formations that are surrounded by water on 3 sides. These are called peninsulas. Peninsulas are found everywhere water and land meet. Some famous examples are the country of Italy, the U.S. state of Florida, and the Arabian Peninsula.
Boy, it seems like there are interesting land formations almost everywhere. Probably the only place you can't find them is on the bottom of the ocean. Right, Geo?
Actually, Iggy, I'm going to need a little help on that. My files aren't complete.
Then let's call up the Kids Into Doing Science Club for more information.
Hello, Kids Into Doing Science. This is Sarah speaking. How can I help you?
Hello, Sarah. This is Geo and Iggy again.
Hi, fellas. What do you need to know?
Sarah, can you tell us if there are land formations on the bottom of the ocean?
Sure, just let me get the images. Here we go. See, the bottoms of the oceans aren't just flat, like bathtubs. There are underwater mountains, including volcanoes. Some of these reach all the way up and out of the water to form islands. There are also wide, flat, deep plains, and even deeper canyons.
Gee, it's almost like the land was flooded over.
That's actually true in some cases. Some of the underwater canyons along the coast were once dry canyons above water.
Thanks a lot, Sarah. That was very helpful.
You're welcome. See you guys later.
Geo, we've seen a lot of land formations, some of which have been underwater. But don't some of the features on the Earth involve water?
You're absolutely right, Iggy. And two of the most important of those features are rivers and streams.
Why are they so important?
Because flowing rivers and streams cause changes in land formations. You see, rivers are formed by...
Oh, I know. The rain falls on the land and it runs off downhill. First it collects into little creeks, then into larger streams, and finally into big rivers, which eventually empty into the oceans of the world.
Very impressive, Iggy. And along their way, streams and rivers wear away and cut into the ground, creating valleys and canyons as they flow. Valleys can be wide and shallow, with lots of water and plants in them, or they can be steep and cut more like a V. Very steep valleys are called canyons. They can be small or large. A good example is the Grand Canyon. Over millions of years, the Colorado River created the Grand Canyon as it slowly cut down through the layers of rock. As rivers cut into the land, they carry away rocks and soil. Much of this will someday reach the ocean.
What happens then?
When a river meets the ocean, it slows down, dropping the rocks and soil it has carried downstream. Over time, these materials can build up into an area called a delta. The Mississippi Delta in North America is one of the best known in the world. Deltas usually have very rich soil and are great places for farming. So, Iggy, now that you have an idea of how some of the land formations are shaped, how would you like to see a demonstration of this in action?
That sounds like fun.
Moving water is a powerful force. It can change the Earth's surface in a hurry. But some of the biggest changes in the Earth's surface occur when moving water has lots of time to work. Not even mountains can stand up to moving water wearing away at them for thousands of years. Today, we are going to demonstrate how moving water affects land formation. For our demonstration, you will need a large baking pan with high sides, clean, moist sand mixed with pebbles, a large paper cup, water, and a notepad and pencil. First, let's create a mountain slope. Shape the sand and pebble mixture against one end of your baking pan into a mini mountain. Now form the mountain so that it slopes down toward the opposite side of the pan. Make your slope drop steeply at first, then have it gradually level out so that it is nearly flat. You should end up with a thin edge of sand just before it reaches the opposite end of the baking pan. Now use your pencil to carefully poke several holes in the bottom of the cup. The cup will be our rainmaker, or source of moving water. What do you think will happen when the rain falls on the mountain? Draw what you expect to see. One partner should hold the cup steady over the top of the mountain while the other partner slowly pours water through the cup. Observe what happens as the cup rains on the mountain. Draw what you see in your notepad. There should be channels or trenches worn into your sand mountain where the moving water carried sand away. Some of these will be small and shallow like a stream bed. Others will be deeper and larger because more water moved through them, just like a riverbed. These deep riverbeds may have created tiny valleys in the side of your mountain. The water should also have pooled at the far end of the pan. This is your ocean. Much of the sand that was carried away from the mountain will have been left here. This is your river delta. You should repeat this demonstration once or twice, pouring the water faster, then slower. When you're through, see if you can make some conclusions about how moving water affects land formations. For example, how does the speed of the moving water affect the landforms? You should see that where the water moved faster, it dug deeper and carried away more sand. Where the water moved slower, the river and stream beds were wider and shallower. But remember, this was only a demonstration. Although a model like this gives you an idea of how moving water, like rain, affects landforms, in the real world, things usually happen much slower, often over thousands or millions of years.
Well, Geo, my circuits are certainly abuzz. These land formations just keep getting better and better.
But so do the forces that wear away at the land. Rivers do it, but so do wind, rain, and ice. All these things are part of weathering, or the breaking up of rocks, and erosion, or the carrying away of rocks and soil. You've seen how the Colorado River slowly cut the Grand Canyon. Valleys are cut in this same way. But wind-blown sand can also carve the land formations. These rocks were cut by wind. Buttes are shaped by wind and rain that cut away at plateaus and mesas. Over millions of years, entire mountain ranges can be worn away by all these forms of weathering and erosion.
And all the rock worn away from the land ends up in river deltas, right?
Some of it certainly does. But the material worn down from mountains can fill the valleys between mountain ranges and form plateaus. It can also pile up in wide river valleys or spread out over plains.
I understand this pretty well. Water and wind and all that. But just how does ice create landforms?
This rugged coastline is part of the Kenai Fjords National Park near Seward, Alaska. The huge park has many steep-sided bays called fjords, where large fingers of ocean water reach deep into the coastline. But these fjords were not created by the ocean. They were carved out of the solid rock by giant moving sheets of ice called glaciers. You see, this area gets a great deal of snow each winter. At higher elevations, all that snow can't melt during the short summer. Much of it packs down into ice that builds up, layer after layer, year after year. This has created what is known as the Harding Ice Field, which covers most of the park and can be hundreds of meters thick. As you can see here, it nearly buries the mountaintops. In some areas, this ice field can be crossed on skis. But in other areas, the ice field is a dangerous maze of huge cracks and crevices that can be hundreds of meters deep and filled with jagged formations of ice. The tremendous weight of all that ice causes it to slowly move downhill, traveling about half a meter or 2 feet each day. As it moves, the crushing, grinding ice tears away rock and carries it along, scraping it across the land. Over thousands of years, this process has gouged out many valleys in the coastline. And though the climate has warmed a bit in the last few hundred years, 40 of these valleys are still filled with glaciers. giant, slow-moving rivers of ice that constantly dig the valleys deeper and farther back into the mountains. Many of these glaciers reach all the way down to the ocean, where the ice tumbles into the water when it breaks free. At times, the coastal waters are a giant slush of this ice, which the seals don't seem to mind. Where the glaciers have disappeared, summertime exposes wide green valleys that are a home to many wild animals. The land is slowly sinking in this area of Alaska, and the ocean is slowly filling these valleys, creating the long fjords that give the park its name. Land formations, created over many years, with a little help from a lot of ice.
Well, Iggy, you've downloaded a lot of data on land formations. You've pretty much got the whole basic story.
The 1/4 of the Earth's surface that is land is constantly changing. Continents formed and moved over many millions of years, separating the one world ocean into smaller parts. And on those continents, there are mountains, and valleys, and canyons. There are mesas and buttes, plains, plateaus, and deserts.
And in the ocean?
Many of these same features are found on the floor of the ocean. But where the land and ocean meet, there are islands and peninsulas. Water also creates formations on shore, through rivers and streams, which can build deltas. But rivers are only part of the weathering and erosion of the land, which shapes it and wears it away to be deposited in new places, finally reaching the ocean. Wind, rain, and ice can also erode the land.
Very impressive. What you've stored in those memory banks of yours is just the beginning, but you've done well, Iggy.
You could even say that a lot of new information has landed in my files, and I've certainly formed some new ideas.
Now I'm going to show you how to make the Landform Dinosaur. Grab your crayons and your paper and let's get started. Okay, the first thing you need is a pencil. Then you're going to need blue, yellow, and green crayons. I have yellow, I have green, I have blue. Okay, then you will also need a piece of paper, but if you don't have a piece of paper, you can draw in this part of your science notebook. So this is what we've been working on, clay and water drawing, and we're just going to draw a landform dinosaur here. So I'm going to do it both places so you can see what it would look like. So the first part of our dinosaur that we're going to draw is actually not part of our dinosaur. We're going to start by drawing the sun up in the corner. Here's my sun. We're also going to add labels, so the sun is an island. I-S-L-A-N-D. I'm going to add that into my notebook. If you don't have enough room to write the word island, just put an arrow and write it next to it. I-S-L-A-N-D, island. Okay, the next part I'm going to draw is the head. So I'm going to start up here at the top. I'm going to make his head look like this. He's going to have a neck. That's his head. Now I'm going to draw his eye. His eye is a lake, L-A-K-E. So I'm going to draw his head. It's just kind of curved. Here's his eye, L-A-K-E, lake. Then I'm going to draw his mouth. His mouth is just a squiggly line like this. This is a river. R-I-V-E-R. R-I-V-E-R. Okay, now lakes and rivers are made out of water. So I'm going to do those in blue. Let's keep going. Now, I'm going to draw my dinosaur's neck. It's going to go down, and the front of it's going to turn into his foot, which is just going to go back up just a little bit. Okay, the back of the neck is the important part. So it's going to go down, it's going to curve, it's going to go up and make like a little hump. Make sure your hump is round at the top and then round again at the bottom. This is a hill, H-I-L-L. So it's going to go down, up, down, hill, H-I-L-L. Okay, then we're going to draw our mountain. So after this round part here, we're going to go up to a tall point, and then down to a point, and then up to a point, and then down again. So now I have two mountains. I'm going to draw two arrows. I'm going to write mountain, M-O-U-N-T-A-I-N, mountains. So point, down, mountain. That makes an M like a mountain. M-O-U-N-T-A-I-N, mountain. Okay. Now the next part of my dinosaur that I'm going to draw is his tail. So his tail is just kind of going to go up like this and then back down. This is a peninsula. P-E-N-N-I-S-U-L-A, peninsula. A peninsula is a piece of land that is narrow and surrounded by water and attached to a bigger piece of land, a peninsula. Then I'm going to make his back leg. All right, up to make the tail, back down, back leg, peninsula. P-E-N-N-I-S-U-L-A, peninsula. Now I just need to make the belly. Okay, the dinosaur part is done, but I still have some labeling to do. I have two things right here. They're the same thing. They're curved pieces that are surrounded by tall things. Do you remember what those are called? We just learned about those yesterday. Right, a valley, a U-shaped path that's made by glaciers. How about a pointy one? A canyon. A V-shaped one made from rivers. C-A-N-Y-O-N. Valley, V-A-L-L-E-Y. And canyon, C-A-N-Y-O-N. And right here, we're gonna have water. I'm gonna draw some waves. This is a bay, B-A-Y. A bay is protected water that's protected from the rest of the ocean by land. B-A-Y. Okay, now we need to draw the land that the dinosaur is standing on. Here we go. I'm just gonna make it flat against his toes. And this is the plain, P-L-A-I-N. Remember, a plain is just a large, flat piece of land. It has grass in it, so I'm gonna draw some grass. Just like 3 lines stuck together to look like grass. Some of them could be up here, because our dinosaur likes to live on grass. P-L-A-I-N, plain. Okay. Now the only thing we're missing is his toes. Right here and right here I'm going to draw toes. And I'm going to color these yellow because these are going to be my beaches. Remember, a beach is where land and water meet together. It's usually covered in sand. Beach. B-E-A-C-H, beach. Beach. B-E-A-C-H. B-E-A-C-H. Okay, now I need to do some coloring. My beach I'm going to make yellow. My island I'm going to make yellow because islands are usually covered in sand. The plain is going to be green because it's covered in grass. Plains are grassy a lot. Now another plain could be like maybe a desert, but my plain's going to be grassy. Now I need to color in the water blue. So everything around my dinosaur, the sky, is water because that is my ocean. So I'm going to color all of that in blue. I'm going to try not to color my dinosaur, but if it colors on it, that's okay. Make sure that your water surrounds your island. It needs to go all the way around it. Because an island is a small piece of land covered or surrounded by water. Okay, now for your dinosaur, you can color this any color you want. If you want to color it in green, you can. If you want to color your dinosaur a different color, you can. If you want to leave your dinosaur white so you can see the labels, you can. I'm going to leave mine white because I want to be able to read all of the labels. So now we're finished with our landform dinosaur. Thank you for joining me in the Science Corner. I hope you learned a lot about landforms. Keep learning, and I'll see you next time. Bye!